Okay, so note 7.6 is separation of variables, general solutions. So we kind of did something like this when we did implicit derivatives. Remember, implicit derivatives is when we took the derivative with both x and y, and every time we derived y, we wrote what? dy dx. So that means this derivative is 2x plus 2y dy dx equals 0. Okay, once we took the derivative, we did what? Isolate dy dx. So if I do that, that's dy dx is equal to, I would subtract the 2x over, divide by 2y, and get negative x over y because the 2's cancel. Okay. Separation of variables is the same thing, but now we're working backwards. So you're going to start with the differential equation dy dx, and we are going to end with the steps where we have the equation in terms of y. Y equals something for the particular or general solution. Okay, so number 1, I'm telling you guys, it's so fun. Okay. So the idea behind this is we need to get the same variable and everything related to it on the same side. So for example, x and dx need to be on the same side, and y and dy have to be on the same side. That's why it's called separation of variables. So in order to do that, I can multiply both sides by dx. Okay, that will cancel out the dx there. And so I have dy is equal to x squared dx divided by y. And then I could do what to move the y to the other side? Multiply by y. So that means these y's cancel out. And I am left with y dy is equal to x squared dx. Everyone with me so far? Okay, that's the hardest part that we're doing today. The rest is just integration. We know how to integrate. Okay, so from here, once we have our variables separated, we're going to integrate both sides. So the integral of y dy is equal to the integral of x squared dx. Okay, what's the integral of y?
Y squared.
Good, 1/2 y squared, or y squared divided by 2. Okay, same thing. And then every time we integrate, we have to do plus c. But since we're dealing with two integrals that are equal to each other, we can't just simply say c. We're going to say plus c1, because we're going to have multiple c's here. Okay. So this is equal to, and what's the integral of x squared?
1/3 x cubed plus c.
Good, so yes, x cubed divided by 3, or 1/3 x cubed plus c2. The reason why we are separating the c1 with c2 is because these are numerical values. If I say that these are both just c, then it makes the impression that these are the exact same number, which they're not necessarily. Okay. So from here, once I have everything integrated, I am going to get y by itself. Okay. So in order to get y by itself, first I am going to multiply everything by 2 to get rid of that 1/2. So I get y squared plus 2c1 is equal to 2/3 x cubed plus 2c2. Okay. I'm going to subtract the 2c1 over to the other side. So I have y squared is equal to 2/3 x cubed plus 2c2 minus 2c1. And now that the c values are on the same side, okay, again, we don't know what those constant values are. Now we can combine them and just say that this is just plus c. Okay, it's still some value that we do not know. So this just turns into plus c. And then our last step to get y by itself is to do what? Square root. So we have y is equal to plus or minus the square root of 2/3 x cubed plus c. That's my answer. right? Algebra with a sprinkle of calculus. Okay, any questions on 1? Okay. So if you're still copying down 1, what I'm going to do off to the side is just write the steps out for those who like to have the visual of the steps. So our first step was to get the variables on different sides. Okay, so your x is on one, y is on the other. Then we integrate. And then we get y by itself. Okay. Just note that C1 and C2, since they're constants, once they're on the same side, they combine to a general plus C. Okay, and that doesn't mean that C value is positive. Okay, if we're adding a constant, that constant value could be a negative number, right? It could be plus a negative 2. Okay, and we're going to follow these steps for every single problem. Okay, so the only thing that I could see happening here is if, let's say, you forget how to integrate certain things. Okay, however, I feel like all of you know how to do the basic power rule of integration, you know how to integrate natural log, and you know how to integrate e. Those are the most common. Okay, so number 2. Okay, so on number 1, I showed step by step how I got the variables to one side versus the other side. I'm not going to do that anymore. I'm just going to explain it and then write it down. So for number 2, I would move dx to the other side by multiplying both sides by dx. And then I would divide both sides by y squared. That way I have my y's and my x's on different sides. So this would be 1 over y squared dy is equal to sine x dx. Everyone agree? Good? Okay. Then we take the integral, and when I integrate 1 over y squared, that's the same as saying y to the negative 2 power. So I'm just going to rewrite it before I integrate. And now that I have it as y to the negative 2, when I take the integral, this is y to the negative 1 divided by negative 1 plus c1 is equal to, what's the integration of sine? Negative cosine plus c2. Okay, now I need to get y by itself. So right now this is a negative 1 over y. Okay, and if I move the c1 to the other side, what does it become?
Negative C.
Negative c? Always plus c. Always plus c. So this is equal to negative cosine x plus c. Okay, I can't say negative c and I can't say that they cancel each other out. I don't know what those values are. Okay, okay, then I'm going to multiply everything by negative 1. Notice, however, when I do that, is my plus c going to change? No, it's still a plus c. So this is 1 over y is equal to cosine x plus c. And then to get y by itself, I need to do the reciprocal of both sides. So I have y is equal to 1 over cosine x plus c. That is my answer. Okay. Any questions on number 2? Number 3. First, I separate my variables, so I would have to multiply both sides by dx and then divide both sides by y. So I have 1 over y dy is equal to x dx. Take the integral, and I get the natural log of absolute value of y plus c1 is equal to x squared divided by 2 plus c2. Again, the hardest part on this notes is if you can remember how to integrate. That's it. Okay. Once I get to here, I need to get y by itself, so I'm going to move c1 to the other side. Bless you. And that's going to turn into what? Plus c. So the natural log of absolute value of y is equal to 1/2 x squared plus c. And then how do I get rid of that natural log? Good, so take the exponential on both sides. Okay, e and natural log cancel out. And so I'm left with y is equal to e to the 1/2 x squared plus c. Okay, FRQ, that would be okay to leave it. Okay, multiple choice. It may be written in another way, and that is based on if you remember the properties of exponentials. So since we have two things adding in the exponential, that's the same as separating this. So y is equal to e to the 1/2 x squared times e to the c. Okay, so if we're adding, it's separating into two e's that are multiplying. E to the c is just a number, correct? Okay, so I can just actually rewrite this as c. And then to write this correctly, usually we put our coefficient in the front. So this is y is equal to c times e to the 1/2 x squared. That's our answer. Yes.
So when you multiply by e, it goes like this step they will split by goes to the power.
So we're not technically multiplying by e, we're taking everything and making that the power of the exponential to get rid of natural log. So for example, natural log to the power of e is equal to 1. That cancels. E to the power of natural log is equal to 1 because that cancels. So that's what we're doing for each of them to cancel out. Okay, then last one, number 4. Okay, so this time notice how I have an x in both. So before I can start separating my variables, what do I have to do first? Okay, factor by taking out
The x.
just the x?
2x.
The 2x. You take out a GCF, the greatest common factor. So if I take out a 2x, I'm left with y plus 2. Okay. So then I still am trying to get my variables on the correct side, so I would multiply both sides by dx and divide both sides by 1 over y plus 2. So I have 1 over y plus 2 dy is equal to 2x dx. Then I would integrate both sides. And when I integrate the first one, I could use u substitution and set u equal to y plus 2. However, when I take the derivative of u, what am I going to get? Derivative of u. So if I set this equal to u, right, I take the derivative of u, I get 1. So is it going to change my integral? No. So really, I can just look at this and say, well, this is the same as saying the natural log of absolute value of y plus 2. And then, of course, plus c1. Okay, and then this is equal to 2x squared divided by 2, which is just x squared, because the 2's will cancel, plus c2. What's my next step? Move C1 over, and then it becomes a collective C. So the natural log of absolute value of y plus 2 is equal to x squared plus c. Okay, now what?
Put everything to the power of e.
Good. So everything becomes the power of e, and that is to cancel out the natural log. So I have y plus 2 is equal to e to the x squared plus c. Good, which turns into y plus 2 is equal to e to the x squared times e to the c. E to the c is just a number, so that's the same as saying c. So we have y is equal to c times e to the x squared minus 2, because I'm getting y by itself.